Greetings and welcome back to the second in the Stata movie series for Statistical Reasoning. In this movie, I'm going to show you at least some of the analyses I presented the results of in Lecture 2 and show you how to do these with Stata. And to start, I'm going to show you a novel way of opening Stata that has some benefits that we'll explore in subsequent Stata movies. So right now, sitting on my screen, I'm looking at my file manager. This would be your Finder if you're using a Mac. And I'm looking in a particular directory here. And the long and short of it is it's my Lecture 2 directory. There's a subfolder for the Stata movies and datasets. And I have 3 datasets sitting here that were involved in some of the analyses presented in Lecture 2. And the first one is the blood pressure measurements on 113 men. The second one is the heritage health data, and the third one is the Nepali anthropometry for 12-month-olds. So to start, I'm going to look at the blood pressure data and show you how to make some summary measures of that, as well as some graphics that we showed in the lecture. Instead of going to my Start menu, though, to start Stata, I can actually go within my file manager here, in this folder, go directly to the file, double-click on that, and what will happen is it will open up Stata immediately and open up this data set. There's only one variable in these data, and it is systolic blood pressure, but nevertheless the file is opened up as part of Stata opening, and this is very handy. Another thing that has some advantages that we'll show in subsequent Stata movies is that the working directory, the default directory where Stata will look for things or save things if I don't give it a specific instructions, in other words a specific directory path, shows up in the lower left hand part of the screen here, and it's actually pointing to the directory from which I took my data set from. And this is particularly handy if I want to save other operations like changes to the data in that directory, etc. I don't have to go through the whole process of laying out the entire directory path each time as part of the saving process. But we'll hold off on the real illustration of this for subsequent Stata movies. So anyway, let's get started. I want to actually summarize this systolic blood pressure data and get the mean, median, and standard deviation to start. So I'm in the mood for some summary statistics, and well, I've memorized the command for this, and this is one you'll probably internalize if you use it often. Let's start by going to the statistics menu and see if we could figure out where to get these results. So if I go to actually, there's a bunch of options here. The first one looks pretty amenable to my desires, which is to get summaries, tables, and tests. And really I want summary and descriptive statistics. So I'm going to go, I could choose just to get means, but I'll show you this summary statistics option here, the first one on the subsequent menu that comes up, is really handy. So if I actually click on this and then click in the variables window here, I can either click in here and scroll down, but there's only one variable in my data set, which is SPB, systolic blood pressure. I could do that. Alternatively, I could type it in, or the third option is to go click on it in the variables window and it will appear in this box. So there's many ways to get the variables that I want to summarize into this window, sub-window here in the dialog box. And right now I'll just take the standard display and I'll hit OK. And again, notice that Stata will give me the corresponding command that it processed to give this output, and the command is pretty straightforward. It's summarize, and then the variable name SPP tells me there's 113 observations. The mean is on the order of 123.6, which is what we reported in the lecture. The sample standard deviation of these 113 individual blood pressure measurements is 12.865, which I reported as 12.9 in the lecture. And the range goes from a low of 89 millimeters of mercury to a high of 152 millimeters of mercury. So this is a great start. Unfortunately, you'll notice that this display does not include the median, however. So there's an option I can enact with the summaries statistics that will include more sample statistics. If I go back to this dialog box, notice it saved everything I did before. It kept the fact that I had asked for the systolic blood pressure variable to be summarized. But if I go down to options here, and click Display Additional Statistics. Hey, OK. The command that Stata runs to process my request is the same as it was before, but with an additional option, something that comes after the main root of the command, comma, detail, which tells it to give me more than just the mean and standard deviation and range as it had done before. And so what this actually does is it gives me the same information before plus more. So I get the number of observations, the mean, the standard deviation. It gives me the variance, which is that standard deviation squared, but that's not really that useful. It also gives me certain percentiles. The first percentile is 99 millimeters of mercury. The 5th percentile is 103. And the 50th percentile is the median. That's 123 millimeters of mercury. So that's where I got the median from. It also gives me this somewhat confusing. You can't see it. I can't draw it on the screen directly, but there should be a vertical line here separating these two columns, because this column that says smallest has nothing to do with the percentiles columns. The smallest, the 4 numbers that follow under there are the smallest 4 values in the data set, and the largest are the largest 4 values. These do not correspond to the percentiles at all, and this is a little confusing visually, so just so you know that. Okay, well, this is great, you say, but John, you presented some percentiles that were not on that list. You gave me the 25th percentile of 114, and I could have pulled that off this display, and the 75th percentile of 132, which I could have pulled off this display. But what about the 2.5th and 97.5th percentiles, which are somewhat integral to understanding where the majority of the data values lie, right? So we can go back to statistics here, go to summaries, tables, and tests, look for summaries and descriptive statistics, and we're going to have to go down relatively far, but you see there's something here that says centiles with confidence interval. CI stands for confidence interval, and that's a concept we'll get to shortly. Well, centiles is short for percentiles. I'm going to click on this, and then I'm going to ask for specific percentiles. So in my variables window, again, there's only one choice, systolic blood pressure. In the centiles, I can give it whichever percentiles I wish to get. If I ask for the 50th percentile, which is the default, and hit return, this is what the syntax of the command looks like. It says centile systolic blood pressure, comma, centile 50, which seems redundant, but it's just telling it to give me ultimately the median or 50th percentile. But I already know the median from that previous analysis, so I want to get, if I replace centiles here with 2.5 space 97.5, hit OK. I get this command which says give me the centile of systolic blood pressure, and the specific centiles I want are the 2.5th and 97.5th percentiles. Notice those are placed in parentheses next to this second version of centile. And what this tells me is there's 113 observations, and the 2.5th percentile in these data is 100.7 millimeters of mercury. The 97.5th percentile is 151.15, or I round it to 151.2 millimeters of mercury. So this shows you some commands that are useful for summarizing key statistics on a single set of data. And one thing I didn't do when I started this session that I should have was start a log file to actually capture all this information that's gone by on the screen. So I'm going to start that up now. I'm going to go up to my file, go to log, go to begin. I'm in the place where I want to save this. I'll just save that in my datasets folder for now. I could always put it in another folder at some point, but I'm going to call this Stata Movie Lecture 2. I'm going to change this to status format, from status format to the .log format, and hit save. And now, from here on in, everything I do will be captured. So just to capture what I've done thus far, I'm going to rerun the commands I've done already. So I'll go back and I click in the review window, and I can get that first command, summarize SPP. Click on the second command, get that. The centile commands I get. And now I've just repeated the analysis I showed you previously, but it'll be in my log file now. Now the other thing I wanted to do, or that we did in this lecture, was we looked at some graphics. We looked at some box plots and some histograms. And I'm just going to get you started, and then in the next movie I'll show you how to dress these up a little more nicely. But here I'm just going to show you how to get the bare minimum to get started. So if I want to actually generate graphics with Stata, something that's of great help to me is the graphics menu here. This really is useful for figuring out the syntax and making more complicated graphics, as we'll see going forward with Stata movies. So I'm going to go up to graphics here, click graphics, and the first thing I'm going to do is make a histogram. So I'm going to scroll down and hit histogram, and I'll get this dialog box that has a lot of sub-tabs on it that will allow me to make very specific statements about how I want my graph to appear, and we'll explore those in subsequent movies. But right now I'm just going to try and get a working histogram of my only variable, systolic blood pressure. And so you see I changed that. The only other thing I'm going to change here is how I want the y-axis to be presented. The default is something called density, which is not so intuitive. It's a mathematically correct representation, but it doesn't really help us understand the distribution of values in the data set. So I'm going to choose %. This will give me something akin to what I've shown in the lecture, where the bars track the percentage of persons in the sample with that blood pressures in this particular range mapped out by the bar. So I hit OK. Stata will think for a minute, and then this graphic pops up in my window here. So one thing to note is that this graphic appears in a separate pop-up window. It does not appear in the results window. So this graphic will not be saved in my log file, and in the next movie I'll show you actually how to save this graph as a separate object. I'll also show you how to make the fancier, change some of the characteristics to make it visually nicer, give it a title, etc. But this is just to get us started and show you what we can do quickly. The next thing I want to do is create a box plot. So I'm going to go back to graphics, scroll down. Right under histogram, actually conveniently located, is Boxplot. And I'm going to hit Boxplot here, go to variables, choose SBP, and then hit OK. And here's that very basic, no frills, no titles, no etc. version of the box plots I showed you for this blood pressure data in lecture 2. Again, I would have to save this separately, which I'll show you how to do in the next data movie. But notice, for each of these graphics that I created via the dialog box, Stata again takes and puts the command syntax that I could have typed to get the same result and archives this in my command window, which is very helpful. Okay, so now we're going to do similar summary statistics for the length of stay data in the Heritage Health Plan. So I'm going to go up to here and go to open. We're going to open a new data set, which is the Heritage Health for Analysis 2. And notice Stata gives a command that says use this new data set, gives the entire directory path, and it tells it to clear what was already in the data set if there was anything in Stata's memory, which was that blood pressure data. So now we go up to the variables window, and you can see we have a new set of information, and this corresponds to our information from the Heritage Health data set. And so what I'm going to focus on here is the age at first claim. So one trick I can do, I can go back and go through the menus to get things. I can also, something I like to do once a command has been established on one data set, if I'm looking at another data set, or if a command has been established for one variable and I want to repeat it for another, is I'll go up to my command window, click on that. It'll appear in my, I'll go up to my review window and click on that. It'll appear in my command window, and then I can edit this to take out the occurrence of SPP, systolic blood pressure, that I was looking at before. If I go then to my variable window and click on the variable I want to use, like the stay final, it'll just replace it in that syntax. So if I hit return here, this tells me the mean, median, and various percentiles for my heritage health length of stay data, including a mean of 4.25, which I rounded to 4.3 in the lecture, a standard deviation of 4.9, and a 50th percentile or median of 2 days. And then if I wanted, I've got the 25th percentile here, which is 1 day, the 75th percentile, which is 5 days, and if I wanted those 2.5th and 97.5th percentiles, I could go back here and re-up that command I used before for systolic blood pressure, but replace it with length of stay final. And it would tell me that the 2.5th percentile is 1 day, the 97.5th percentile is 20 days. Similarly, for the graphics, I'll actually go back to the box here and use the menus, because this is much easier for graphics, even the simple ones, because usually you're building towards something more complicated ultimately. So let's go to histogram. Notice that it saves everything I had done before with my systolic blood pressure. When it opens, it saved the fact that I wanted to do a histogram of systolic blood pressure, and I want to actually map the percent on the y-axis. So I'm going to hit this R on the lower left-hand corner, reset this. And this is especially useful if I had done a lot of other things to the previous graph that I don't want to do to this one. I'm going to choose from and it only lists, notice there's 4 variables in this data set, but it only lists the ones that are numerical, because it can't graph character-based. So if I hit length of stay final, and then go down to percent here, I get this very bare bones, no frills version of the graph I presented in lecture 2. And again, in the next movie, I'll show you how to dress up the graphs nicely, add appropriate axes labels, put a title on, that sort of thing. And again, I'll have to save this as a separate object, which again I'll show how to do in the next movie. And then finally, I could go back and do a box plot of these data. And notice it has saved what I had before, which was simply the box plot for systolic blood pressure from the previous data set. Luckily, I hadn't made any changes to these other options yet, but I'll still reset this and choose length of stay final. Return. I'll think for a minute, and I get that box plot that I presented in lecture 2 for the length of stay values. Okay. So finally, let's look at the anthropometric data by Nepali children at age 12 months. So I'm going to go again, open a new. I haven't made any changes to these data, so I don't have to save it. Open a new window, new file here, which is the Nepal anthropometry, and you see everything changed in my variables window here. So I could do the same sort of analysis for the weights of these children. I could summarize the weights. One thing I want to show you though before I do that, I'm going to summarize age and just explain something to you. And then in the next movie I'll actually show you how I did this from a larger data set that included multiple ages. But I had subset, this is a subset of a larger data set that includes ages from birth to 5 years. What I did was I actually chose it such that children, in order to approximate what was going on at 1 year, I chose children whose reported age at their visit was between 11 and 13 months. So you can see that the first percentile for age is 11, the median is 12, and the 99th percentile 13. The smallest values are 4 11s, the largest are 13. So the age range in these data is from 11 months to 13 months, because the age of visit wasn't totally accurate, and I thought this would capture children around 1 year old or 12 months old. Okay, so we can do the same thing for the weights of the children. And we see the mean weight for all children is 7.06 kilograms, standard deviation of 1.2, and a median of 7. And we could go through the same process of getting the percentiles and whatnot, but remember, one of the analyses we did in this lecture was to actually break this out by sex and look at the weight differences, the average and standard deviations by sex. So we're going to do something new here that we haven't done and look at this broken out by sex. But first, let's look at what we have with sex. Sex is a categorical variable, takes on two values. A quick and easy way to summarize that is to go to summaries, tables, and tests. Go to frequency tables. A one-way table just means it'll give us the distribution of one variable, and then fill in the box that says categorical variable sex. And this shows us the breakdown of sex in these data. And I'll tell you what these refer to in a minute, because this is a little mysterious, right? It doesn't tell us whether we were dealing with males or females for ones or twos. So we're going to rectify that in a minute. But to start, what I want to do is just go back to summaries, tables, and tests, and I want to present summary statistics. But I want to do it separately by sex. So there's another tab in this summary statistics window. First thing I have to do is reset what I did before, and I'm going to choose weight, and then I'm going to go to this by if in tab, and it's going to say repeat command by groups, and the variables that define the groups are sex. I'm going to hit return here, and what I get is for those who have a sex value of 1, of which there's 124, the mean is 7.377 or 7.4. For those that have a sex of 2, with which there are 112, the mean is 6.72. So now this turns out, if you compare this to the results I presented in the lecture, you'll know that the 1s are males and the 2s are females. But let's do something to help us remember that going forward. And there's something called labeling the values of a variable, which is such that this variable is stored as numeric in Stata, and this will be helpful going forward. But we want to put a text label next to each of these values to remind us of what a 1 means and what a 0 means. So I'll show you what this means. I'm going to go up to the Data tab here, go to Create or Change Data, and this is the wrong place to go. So I'm going to have to figure out where to go to do this. Ah, here we go. So this is, even I, who've used Stata for a fair amount of my life, has to hunt and peck a little bit when I do these analyses to remind myself of where things are. If I go to Data Utilities and go to Label Utilities, and I go down to assign a value label to variables, right? But the first thing I have to do is create the label that I want to assign, so this won't help me. So let's go back here and we'll go to Data, Data Utilities, Label Utilities, and I'm going to go to Manage Value Labels. And what this means is I'm going to create a label here, and I'm going to call it Sex Lab. And I'll put in value here, I'll put 1, and the label I want 1 to have is male. So in this label window, I'll put male, put add, and so it tells me that this label is such that values of 1 will have a text label of male, values of 2 will do female. Return. Okay, so I messed that up. I want to go back and edit the label. 1 is male, and I want to create a value 2, which will have female. Apply that change. Okay, let's make sure it's stuck. Edit label. Okay. Oh, so what I need to do is I had rewritten over what I'd done before. I need to add a new value. So I have 2 for females now, but I lost the 1 for males. So I'll hit 1, do male, go to add. Now they're both there. I'm happy with that. I'm going to close. And let me just show you what happens when I do this command again by sex, sort, summarize, weight. It still says sex equals 1 or sex equals 2. But because I have not assigned this label is floating there in Stata's memory. It is not affiliated with the variable sex yet. So I have to attach this label to the variable sex. So if I go back to Data, and go down to Data Utilities, Label Utilities, and go to Assign Value Label to Variables. Now the variable that I want to attach a label to is sex. The value label, there's only one that I've created so far, and it appears in this window here, but if there were multiple, I could scroll and choose between them, is sex lab. I'll hit OK. And now look what happens when I do by sex. It replaces the value with the text label. So this is more helpful than seeing a 1 and 2 all the time, because I'd have to keep a note on my computer, like a post-it, to remind me that 1s were males and 2s were females. Now I have text labels that will appear in my analyses to remind me of which groups I'm looking at, and that's very helpful. Let's look at how to do the graphics I did, the side-by-side histograms and the side-by-side box plots by sex. So I'm going to go back to graphics here. I'm going to choose histogram. I'm going to clear out what I had before. And now what I want to do is the variable weight. I'm going to get the percent here. But what I want to do is, if I go to by, all the way, this tab all the way over on the right, and this option to draw subgroups for unique values of variables, I'm going to click that. And the variable that I'm going to choose to draw separate graphics for is sex. If I hit OK, I get this histograms that are side by side, graphed by sex. Those don't look exactly like what I did in the lecture because I stacked those. But I'll let you play around with this command at your leisure to see if you can duplicate what I did in the lecture by stacking those, if you're so interested. Again, this graphic won't save. I'm going to close it out for now, and again we'll show you how to save in the next lecture, the next Stata movie. But let's just do the Boxplot version. If I go to Graphics, Boxplot, and now I want to reset what I had before because I don't want length of stay, I want weight. If I go to the Categories command and I hit Group 1, and you can do multiple grouping layers here, but I'm going to, my first grouping variable and my only one is going to be sex. If I do that, I get these side-by-side box plots of. Notice that instead of putting the 1 or the 2 labeling the graphic here, it now replaces that with those text labels I assigned to the variable values. So that's really helpful, again, because it will appear in multiple analyses. Just want to show you one more thing. First, notice that when I did these, the commands that I used or the operations I presented in the dialog boxes were converted into Stata commands that now appear in my review window, and I could rerun again without having to go through the process of the dialog box. And this is especially helpful if I had made a more complex command, changing the titles and the colorings, etc. Let me show you one more thing about the box plot that's a little tricky though. If you want things to look side by side nicely, you would want to go and do what I did here to the Categories window and do that, but it's a little bit hard to remember sometimes. I'm just going to turn this off for a minute because there's also a window like we saw in the histogram that says by. And that seems like you might think this does the same thing as what we just did, but I'll show you the difference. If I do the box plots by sex instead of using the Categories tab, what I get is it's slightly different. But it creates two different. There's a split between the graphics. It's not really a big deal visually, but the presentation is slightly different. All things considered, we wouldn't have any difficulty interpreting this version, but I just like it a little bit better when everything is fused together on a single graph. That's just a stylistic preference on my part. Alright, so we're done with this session. Hopefully this gives you some sense of what you can do in terms of summarization and give you a heads up on to what you can do graphically in Stata. I'm going to close my log file so I have a record of what I've done. I'm going to go over to my command review window, select everything, send it to the do file editor, and save it just in case I want to replicate my analyses somewhere down the line. So I'll call this Stata Movie Lecture 2, but not log. It'll be .do when I save it. And hopefully this gets you excited about the capabilities and things you can do in Stata, and you'll look forward to seeing more details about the graphics in the next movie.